Okay. In our last session, I've just discussed about a quadratic function. There, I have discussed about the uh, general form of a quadratic function that was just like this: f of x equals to ax squared plus bx plus c, right? And then we if we make it a quadratic equation, that is ax squared plus bx and then plus c equals to 0. So the solution of this quadratic equation is just like x equals to negative b plus minus root over b square minus 4ac by 2a, right? That is the basically solution of a quadratic equation. That means if you are given a quadratic equation just like this, that is, you can say 2x squared plus 5x plus 6 equals to 0, plus we can say here plus 3, then it will be easier to find. Okay, plus 3 equals to 0. So then what will be the solution of this quadratic equation? That means if we compare this equation with the general form of quadratic equation, then we are getting here coefficient of x square is a, right? And here a coefficient of x square is 2. So we can write a equals to 2. Okay. And then coefficient of x is b, and here 5. So we can write b equals to 5. And then constant term c equals to 3. Okay, so if we just put here in the solution formula, that is x equals to, so negative b, that means negative 5, and then plus minus root over b square, that means 5 square, then minus 4 times 4 times a is 2, and then c is 3, divide by 2a, that means 2 times 2. So what will be the solution here? That means here negative 5 and then plus minus here root over 25 minus 24, that is 1. So root over 1, that means 1, and then by 4. So we are getting here, if we consider plus, then we are getting here negative 5 plus 1 by 4, and then negative 5 minus 1 by 4. So basically we are getting here negative 4 by 4, that is negative 1, and from here negative 6 by 4, that means negative 3 by 2. Okay, this is the basically formula solution of this quadratic equation. Okay, now uh, if we move to the, here is the basically the formula we used, and then we also talked about the vertex point and the equation of axis, and then minimum point and then maximum point, right? If the shape is concave up, then we'll get minimum point. If the shape concave down, then we'll get the maximum point. Okay, and then now we will move to the polynomial function. So polynomial function is basically in the form f of x equals to, here we can say a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus just, and then dot dot plus a naught. oh, we can say here an in this form. Okay, now if we go for an example, that means here power for a polynomial function, the power of the variable must be integer number. Okay, positive integer. That means we can say f of x equals to 3x cubed plus uh, 3x square or plus 2x plus 5. This is a polynomial function. And if f of x equals to 3x power negative 3 plus 3x square plus 2x plus 5, so then we consider this one is a polynomial function, right? Right. Positive, right? Okay. Yeah. So because of this one is not a polynomial function. Similarly, also if we write f of x equals to 3x cubed plus 2x power 1 over 2, then plus 2x plus 5. So this one is a polynomial or not? Will it be a polynomial? No. Look at positive, but positive integer, positive integer. So this one is a fraction, not integer number. That's why it will not be a polynomial function. Okay. And basically the domain of a polynomial function is a set of all real numbers. That means domain will be set of all real numbers, that is negative infinity to infinity. Okay. And then a rational function. Rational function. So here f of x equals to we can say here n of x and d of x, and here n of x and d of x both will be polynomial. Here n of x and d of x both will be polynomial. So we can say here f of x equals to x square plus 2x plus 5 over x minus 5. So this one is a rational function. Okay. Okay. uh, and if we go for another example, then here we are given so many examples here. F of x equals to 1 over x, and then g of x equals to x minus 2 over x square minus x minus 6, and then h of x equals to x cubed minus 8 over x. All of them are polynomial, rational function, rational function, rational. Okay. So basically this one is the general form of a rational function. That means f of x equals to n of x over d of x, and here the condition is g of x must be not equals to 0. And the domain is the set of all real numbers such that d of x not equals to 0. That means if we are given a rational function, that is f of x equals to 5 over x minus 2. Okay, this one is also a rational function. So domain will be domain for domain x minus 2 not equals to 0. So that means x not equals to 2. That means here for domain. Okay, so domain will be here. Yeah, yeah, that is negative, right? We can write this one as, if we follow number line, yeah. So it will be negative infinity to 2, and then 2 to positive infinity. So it will be negative infinity to, yeah, yeah, 2, yeah, yeah, yeah. This one is also correct. So we can write this one as 2 to infinity. Okay, and then if we move to exponential function. So just we learned about polynomial and then rational. Now we are moving to exponential function. So exponential function basically this the standard form of an exponential function, that is f of x equals to b power x. Okay, and here the condition is b must be greater than 0 and b not equals to 1. So if we just look at this one, this type of functions are called exponential function. Here basically b is called the base. Here b is called the base and x is power, called power. So the condition for exponential function, base must be positive. Okay. And also base not equals to 1. That means if we have 1 power x, that is equals to 1. So the function becomes a constant function. The function here becomes constant function. That means f of x equals to 1. It will become 1. That means if we put any number in place of x, that we will get a constant term, that is all time 1. So that means if we put f of 2, then we will get 1. If we put f of 1, we are getting 1. And then if we put f of 3, also we are getting 1. So that means this type of function is called a constant function. Okay. And then there are some properties related to exponential function. Uh, these are, if we are given here a power x times a power y, so we can write it as a power x plus y. Do you know this? Okay. And yeah, okay. And also if we have a power x over a power y, then we will have a power x minus y. So these are related to exponential functions. And then also if we have a power x equals to a power y, then we can write x equals to y. Okay. And if we have a power x equals to b power x, then also we can write a equals to b. uh, am I moving too first? Is it okay? Okay, okay, okay. And then the exponential function here. So we have here f of x equals to b power x. So if we just use a constant term in place of b, then we are getting f of x here 2 power x. So this one is an exponential function. Okay, okay. And now if we just use e in place of 2, that means b, and basically b is an irrational number, and the value of e is 2.71828, and then so on. So e basically just like an pi, just like pi, is an irrational number. Okay, so now if we just place here, substitute b with e, then we are getting f of x equals to ex. So this one also an exponential function, and the function here, the graph of this function, that is this. And if we put here f of x equals to e power negative x, then the graph of this function is just, and both the characteristics of an exponential function is uh, both the graph both the graph will intersect y-axis at 0 1 point. Okay, if we go for the application of exponential function, then uh, try to solve this one, that is uh, exponential growth. And cholera is an intestinal disease, is caused by a cholera bacterium that multiplies exponentially. That means the disease cholera increases exponentially, and the function is defined by n equals to, here n equals to n naught times e power 1.3h6 times t, and here where n is the number of bacteria present after t hours, n is the number of bacteria, and n naught is the number of bacteria present at the starting time, that is t equals to 0. If we start with 25 bacteria, how many bacteria will present, number A, in 0 0.6 hours? That means we are given a function that is n equals to n naught e power 1.386 times t. Okay, this is the function. Here n naught basically is the number of bacteria at t equals to 0, at t equals to 0. So here t equals to 0, that means at the starting. Okay, at the starting number of bacteria, that is 25. So n naught equals to 25, and then we are asked to find the number of bacteria in 0 0.6 hours. That means t equals to 0 0.6. So what will be the number of bacteria? That means here n equals to 25 times e power 1.386 times 0 0.6. Okay, so If we calculate this, then we'll get the number of bacteria. And similarly for 3.5, just we have to substitute t with 3.5, then we'll get the number of after 3.5 hours. Okay, so that means basically diseases just like bacteria are growing exponentially. Okay, here is the solution. Solve for n when t equals to 0.6. So we are getting here 57 bacteria. That means after 0.6 hours, it will increases to 57 and started at 25. And then after 3.5 hours, the number of bacteria, that is 3,197 bacteria. Basically, this is the modeling of functions. That means functions are used here. Compound interest. This one also related to exponential function. So the formula for compound interest is basically a, if we consider it as future value equals to present value times 1 plus r over m, then power m t. Here, basically present value, that means principal amount. Okay. Yeah. And then r is the rate of interest, and m is the number of compounding periods per year. That means if the interest rate compounded monthly, then the value of m will be 12. If the interest compounded quarterly, then what will be the value of m? Quarterly, it will be 4 quarter. Oh no, m is the number of compounding periods per year. 4. Okay. So if uh, the rate or the interest compounded half yearly, then the value of m will be half yearly. If compounded half yearly, 2. 2. Half yearly, that means how many times? How Yeah, 6 months, that means in a year 2 times, right? So if the interest is compounded monthly, that means in a year 12 times, right? So if quarterly, then the value of m is 4. That means the interest compounded quarterly. So how many times in a year? That is 4 times. 4 times. Okay. And if the interest is compounded half yearly, that means in a year it will be 2 times. So the value of n is 2. Okay. And here t is the number of years. So if we use this one, then So what will be the solution of this problem? That means here if 10%. So 10% r equals to 10%. That means 0.1, right? That means 10 divided by 100. Yeah. So r equals to 0.1%, and then present value. That means t is here 1000, and compounded monthly. Compounded monthly. So m equals to 12, and then 10 years. So t equals to 10. Okay. So if we put these values in the formula, then we will get the result. And then logarithmic function. So here in logarithmic function, basically exponential function and logarithmic function, both are inverse to each other. That means if we put here uh, 2 power 3, that means 8, right? Okay. And if we convert it into logarithm, then we will have log 2 base 8 equals to 3. So there is a relation between exponential and logarithmic function. Basically, a concept of logarithm came to express a large number into a smaller one. That means if we if I give you an example, that is uh, 1. So this one looks like a big number, right? So basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that means 10 power 13. Okay, now if I just put a log sign, log 10 base in front of this, then the result is 13. That means log, this term log 10 just converted the number into a smaller one. So if I do you have any idea about a logarithm? Do you have any idea about logarithm? Do you have any idea about logarithm? No. Okay. Okay. Then okay. Basically, the relation uh, of logarithm with the exponential, that is here y equals to log uh, base b x. If we convert it into exponent, then that is equivalent to here x equals to b power y, which I have already mentioned. That is, if we put here 2 cube equals to 8, then if we convert this, then here log and base will be 2, base here 2, so it will be base 2, and this number 8 here, then the power is 3. That means here, what does it mean? Here, if we just convert 8 in terms of uh, base 2, okay? So here